Here's another exam question about reactions. Hydrogen, H2, which is a gas, and nitrogen, N2, also a gas, react to form ammonia, NH3, also a gas. And this is the reaction which forms ammonia. First question is to define the term 1 mole. 1 mole is the SI, the System International, unit for particles, for number of particles. 1 mole is the same as 6,02 times 10 to the power 23 particles. There are a number of ways to define a mole, so I've given 2 already. Another way you can define it is that 1 mole is the number of particles that are inside 12 grams of carbon-12. How many moles of ammonia will be produced from 1 mole of hydrogen gas? So here we have the reaction. I'm just repeating what's written up at the top. And it is a balanced equation. That's very important. And the reason why that's important is that that gives us the molar reaction ratio. 1 mole of nitrogen reacts with 3 moles of hydrogen to produce 2 moles of ammonia. And we are asked here, how many moles of ammonia will be produced from 1 mole of hydrogen gas? So our question is, how many mole ammonia will we get from 1 mole of hydrogen gas? And to answer that question, we need to multiply this by a conversion factor which comes from the equivalent values for this particular reaction, the reaction ratio for this particular reaction, making sure that moles of hydrogen are at the bottom and moles of ammonia are at the top. So it's important not to get confused between the question, this is the question, how many moles of ammonia do you get from 1 mole of hydrogen? That's the question. Don't get confused between that and the ratio, the reacting ratio, which is 1 mole is to 3 mole is to 2 mole. And we use that ratio in which they always react as our conversion factor. 2 moles of ammonia are produced every time 3 moles of hydrogen react. And in that way we can find out, well, what if we don't have 3 moles of hydrogen? We only have 1 mole of hydrogen. How many moles ammonia will then be produced? So we apply the reaction ratio to this particular instance, this particular question. 1 times 2 over 3, which is equal to 0,66 recurring. We round that off to 0,67 moles of ammonia. Question C says, 10 centimeter cubed of nitrogen reacts with sufficient hydrogen gas. The temperature and pressure remain constant. We have to calculate the volume of ammonia gas that's formed. Now I'm going to do this in 2 ways. One is a long way, which is actually maybe slightly wrong, or rather unnecessary, but I think it will probably make more sense to you. And then I'll show you the better, quicker way, which I think if I start with maybe might not make complete sense yet. We start by writing the balanced equation. Why do we need the balanced equation? Balanced equation gives us the mole reacting ratio. 1 mole of nitrogen always reacts with 3 moles of hydrogen to form 2 moles of ammonia. Remember, this is a ratio. This is not this particular situation, this particular question asked in C. No, this is the general reaction ratio. We are going to write our question, C, down here at the bottom. The top part is about the ratio. Let's go back to our question and see which parts of this ratio are useful to us and how must we convert this ratio to be helpful in this particular question. That depends on what we are asked, which is volume of ammonia. So volume of ammonia, let's say decimeter cubed of ammonia, is relevant to this question, so we need it in our ratio, our modified ratio if you like. So we are asked the volume of ammonia. What are we given? 10 centimeter cubed of nitrogen react. So that's what's given. It's again a volume. So let's say decimeter cubed nitrogen is to decimeter cubed ammonia. I haven't finished yet. How many decimeter cubed is to how many decimeter cubed? Nitrogen to ammonia. So we can ask ourselves, 1 mole of nitrogen, how many decimeter cubed is that? 2 mole of ammonia, how many decimeter cubed is that? As I said, I'm going to do this maybe slightly wrongly first, because we have not been told here that this is at STP. We were told that the temperature and pressure remained constant, but it's not at STP. By But you will get the right answer if you assume it is at STP. So let's do that. For now, 1 mole of nitrogen at STP would have a volume of 22,4 decimeter cubed. 2 moles of ammonia at STP would have a volume of 2 times 22,4 decimeter cubed, 44,8 decimeter cubed. So we have now got the mole ratio in a ratio which is valuable for this question, which is a volume-volume ratio. Now we can get to our particular question. And our question is, what is the volume? So let's say, how many decimeter cubed of ammonia are formed when 10 centimeter cubed of nitrogen reacts. Okay, now we need to be careful because this is centimeter cubed, but we actually need decimeter cubed. So you could have just immediately divided 10 by 1,000 to convert centimeter cubed into decimeter cubed, which is 0,01 decimeter cubed. So then we could just straight away have written here 0,01 decimeter cubed. But maybe let's go the long way. So we need to multiply this by, actually in this case, 2 unit factors. One to convert from centimeter cubed to decimeter cubed. So let's start with that. So we have centimeter cubed, still nitrogen, and we change that to decimeter cubed, still of nitrogen, and we know that 1,000 centimeter cubed is the same thing as 1 decimeter cubed. So now we've got rid of centimeter cubed nitrogen, but we still have nitrogen. We don't yet have ammonia. So we need another conversion factor. And this conversion factor has to do with the ratio in which nitrogen and ammonia react with one another in this particular reaction. So we need decimeter cubed of nitrogen at the bottom to cancel away decimeter cubed nitrogen. And we need decimeter cubed ammonia at the top, because that's what we were asked. And we use our reaction ratio as that conversion factor, the reaction for this particular reaction. So we know that 22,4 decimeter cubed of nitrogen reacts to form twice that amount of ammonia. And then we can get our answer. Notice that the first step is the same as what we could have just done without needing to write a unit factor. 10 divided by 1,000, which obviously is 0,01. And can you see that 2 times 22,4 divided by 22,4 is simply equal to 2. The 22,4s cancel away, which is why it doesn't matter that it's not at STP. This 22,4 is actually irrelevant. The ratio is simply 1:2. 1 decimeter cubed is to 2 decimeter cubed. We could also write it as 1 centimeter cubed is to 2 centimeter cubed. It's a ratio. It's just 1:2 in the format of volume. And as long as we use the same unit for nitrogen as for ammonia, it doesn't matter whether it's centimeter cubed or decimeter cubed. So the reaction ratio is 1 decimeter cubed is to 2 decimeter cubed, or 1 centimeter cubed is to 2 centimeter cubed. You'll see just now how we get the same answer, even if we use centimeter cubed. But let's continue here. Our final answer we find is 0,02 decimeter cubed of ammonia. And now let's get the answer in the quicker, more correct way that I said we could have done from the start, but I was scared that maybe you wouldn't understand it if I did it immediately. In this method, we realize that the mole reaction ratio is the same ratio as a volume reaction ratio. So 1 mole is to 3 mole is to 2 mole. Therefore, 1 centimeter cubed is to 3 centimeter cubed is to 2 centimeter cubed. Or 1 decimeter cubed is to 3 decimeter cubed is to 2 decimeter cubed. And which of those you want to do is just whatever is most convenient. Now in this case, centimeter cubed is given. So actually it's most convenient just to use centimeter cubed. 1 centimeter cubed of nitrogen will always produce 2 centimeter cubed of ammonia with this particular reaction, as long as temperature and pressure remain constant. It doesn't have to be at STP. So this is the volume reaction ratio. And realizing this simplifies the procedure a lot. Question is, what's the volume? Now we can give it in any unit we want actually. Let's give it in centimeter cubed. How many centimeter cubed of ammonia gas is formed from 10 centimeter cubed of nitrogen gas. We multiply that by a conversion factor, which is the reaction ratio for this particular reaction, with centimeter cubed of nitrogen at the bottom to cancel that away, and centimeter cubed of ammonia at the top to introduce the required unit. Then we look at our ratio and we know that 2 centimeter cubed of ammonia will form from every 1 centimeter cubed of nitrogen. 10 times 2 is 20 centimeter cubed of ammonia. If we go back and see what we did before, we found 0,02 decimeter cubed of ammonia. Now we found 20 centimeter cubed ammonia. 20 centimeter cubed. How many decimeter cubed is that? Divide by 1,000 and we get 0,02 decimeter cubed. So 20 centimeter cubed is the same thing as 0,02 decimeter cubed. So we found the same answer whether we did it that long complicated way, taking 22,4 decimeter cubed for each mole, as when we did it this much simpler way, when we didn't care about the 22,4 decimeter cubed, because in any case it's not at STP. We simply used the reaction ratio, the volume reaction ratio of 1 centimeter cubed is to 2 centimeter cubed. You do just have to be very careful here, because unlike in the first example, these two are not equivalent. 1 mole is not 1 centimeter cubed. And so you would not be able to solve a question where you use, say for example, that and that in your unit factor, because they are not equivalent to one another. But 1 centimeter cubed is to 2 centimeter cubed. They are equivalent to one another for this reaction ratio. Why? Because always a volume reaction ratio is the same numerically as a mole reaction ratio. And for this equation, the reaction ratio, the mole reaction ratio is 1 is to 2 for nitrogen is to ammonia. And therefore the volume is also 1 is to 2. The volume reaction ratio for nitrogen is to ammonia is also 1 is to 2, because mole reaction ratios are the same numbers as volume reaction ratios. But you can only use that fact if both your question, your required value here, and your given information here are both volumes. Then you can use the shortcut that I've given here.
And before we go, have you already liked? Have you subscribed? Have you left me a comment? And please go and visit my website. You'll find a lot of resources there, and they're categorized in a way that will make it very easy for you to find what you need. Until we meet again, learn science!